Example 2. Find the intercepts of the functions and determine the number of turning points. So to find the intercepts of the function, we are going to think about the x and the y separately. Let's first find the y-intercept by letting x equal 0. So if I look at f of 0, I'll have 0 to the 4th power minus 16. So it looks like we're getting negative 16. Our y-intercept is 0, comma, negative 16. To find our x-intercepts, we're going to think about factoring this. We are letting y equal 0, so that means on the left-hand side we have 0 there in the place of y. I'm going to rewrite this in a different way. This is a quadratic in disguise. I'm going to do a variable exchange. Let's let u equal x squared, and then u squared is going to be x to the 4th power. So this will be a rewrite as u squared minus 16. Well, this now looks like a difference of squares that we can factor into u plus 4 and u minus 4. And now I'll go back and rewrite, instead of u, I'll go back to write this as x squared plus 4 and x squared minus 4 equals 0. The x squared plus 4 cannot be factored because if we think about the graph of that, it's an x squared and it's raised up by 4, like this. And so we know that it doesn't cross the x-axis, so there are no x-intercepts there. But the other one is also a difference of squares. So we'll leave the first one alone, and we'll rewrite this guy as x plus 2, x minus 2. All right, now if we want to find the intercepts, we're going to set each part of this equation equal to 0. So we get that either x squared plus 4 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. We already said that this one doesn't give us any intercepts because we can't have x squared equal negative 4, right? When we square something, we always get a positive number. So that doesn't lead to any intercepts. But for the other two, we get x is equal to negative 2 and x is equal to positive 2. So for our x-intercepts, I think we have negative 2 comma 0 and 2 comma 0. So as we think about graphing functions that have higher exponents or higher degree, we want to use the y-intercept and the x-intercept as points to sort of frame the graph for us. Let's look at a second example here. For example B, this looks like it's partially already factored a little bit. It looks like we have an x that's factored out to the front. So we need to think about whether or not we can factor what's in the parentheses there. I want to find two numbers that'll multiply together to give me negative 8 and combine to give me negative 2. Negative 8 is going to be one positive number and one negative number multiplied together. I can get 1 times 8, I can do 2 times 4. So it looks like this will give us numbers that are 2 away from each other. I think I want the 4 to be negative and I want the 2 to be positive. So I'm going to split this up into a plus 2x minus 4x, and then I'll leave the x squared and the minus 8 there. Let's have this x sitting out on the front here. Okay, now what we'll do is we'll factor by grouping because I have 4 terms. By looking at the first 2 terms, I can pull an x out to the front, and I'm left with x plus 2. I want my second set of parentheses to match, and then I want to look at these 2 terms here and decide what would I have needed to pull out of, factor out of those to end up with an x plus 2 in parentheses. And I think that if I put let's see, minus 4 here. Let's check. This will give me minus 4x. This will give me minus 8. Yeah, that's going to work. Again, when I factor by grouping, I need these two items to match one another. All right, I still have this other x out in the front. I don't want to lose that. And then inside the square brackets, we'll have x minus 4, x plus 2. And then we've got an x out in the front. Okay. To find the y-intercept, we'll let x equal 0. And when I plug 0 in, right here, the whole entire thing is going to be equal to 0. So I'm just going to get 0 here. So I think my y-intercept is 0, 0. Then to find our x-intercepts, we're going to let y equal 0, or we're going to solve this equation. 0 equals x times x minus 4 times x plus 2. So I get from this first variable here, I get that x is equal to 0, or from the second set of parentheses there, or the first set of parentheses, I get x minus 4 equals 0, or x plus 2 equals 0. So let's see. This gives me x equals 4. This gives us x equals negative 2. So my x-intercepts are 0, 0. This actually matches our y-intercept there. 4, 0, and negative 2, 0. All right, one more example. This is also sort of partially factored. This first set of parentheses can't be factored any further, so let's focus on the second set of parentheses. I have 4x squared minus 1, which is a difference of squares. If I take the square root of this, I get 2x, and if I take the square root of this, I get 1. So I think this is going to factor into 2x plus 1 and 2x minus 1. Right, we want to factor things completely before we try to find the intercepts. To find f of, we want to find our y-intercept, so we're going to let x equal 0. So we're finding f of 0, which is, let's see, 3 times 1 times negative 1. I'm just plugging in 0 here, here, and here. And so it looks like we're getting negative 3. So our y-intercept is 0, negative 3. For our x-intercept, we're going to let y equal 0. And we're solving the equation 0 equals x plus 3 times 2x plus 1 and 2x minus 1. So we have x plus 3 equals 0, or 2x plus 1 equals 0, or 2x minus 1 equals 0. This one gives us x equals negative 3. Here we'll get 2x equals negative 1. X is negative 1/2. And here we'll get 2x equals 1, or x equals 1/2. So I think my x-intercepts are going to be negative 3, 0, negative 1/2, 0, and 1/2, 0. Again, the reason that we're reviewing finding the intercepts is that these are going to be key points for us to graph, and we're going to be focused on graphing polynomials that are higher degrees than we've done previously, which was mostly squared.